What's up, guys? It's Tech, and today we are going to go over the bisection method, but this time we are going to use Matlab. So in our previous video, we did a bisection method problem by hand, and we only did 3 iterations. This time we're going to do 8 iterations, and we're going to do it in Matlab. So since bisection method is very repetitive and it's a lot of calculations in your calculator, Matlab is by far probably the best way to do it. So I've already gone ahead and wrote a code for this, and I'm going to step you guys through it on how it goes. So if you don't remember from the last video, or if you haven't seen it, you should definitely check it out, because that's going to have the problem in it, and it's also going to have our function equation. So this is just how to do it in Matlab. So to start off for your Matlab code, you're definitely going to want to clear everything, CLC and clear. That's going to clear your workspace and just make sure nothing else is running, you don't have anything open. You want that beginning of the code. Next, you want to set your lower and upper bounds, which were given in the problem. So we were given XL and X upper. So we're going to step through this step by step. So we clear everything, so we got XL. XL is going to pop up in our workspace, and X upper will also pop up in our workspace. Now there are many different ways to code this in Matlab. This is just the way I did it, just because I think it's simpler for you guys to follow along. It's also very simple if you're not too familiar with Matlab. It's not using too much. So next what we want to do is we want to get our functions for our lower bound and our upper bound. So if you remember in the previous video, we used the lower and upper bound to check if there's a sign change and where the root is. So if the root is between the upper and XR or the lower X and XR, sorry. So with that, that's what these functions here are doing. It's just setting a function up for those two variables. So what that is gonna do is it's gonna calculate the function of 5 and the function of 10. So that means the function of our lower bound and our upper bound, we get 4.5 and negative 20.5. So if you see there is a sign change between these two, that means there is going to be a change, a root in between there, at least one root. So now what we want to do is start off our for loop, and we're going to do it for 8 iterations. Could do it for more iterations. More iterations is probably going to mean it's going to be more accurate. So once again, we can take these functions that we wrote up here, we're going to put them right into our for loop, and now throughout the for loop they're going to be changing. So we're going to step through the first sequence of our for loop. This is just kind of repeating what's already happened. So we already know XL and X upper are going to equal 10. So we already kind of did the first step here. You could take these out. I just wanted to write the equations out. So you see that our equation is f of x equal to negative 0.5 times x squared plus 2.5 times x plus 4.5. So just so you saw the equations. So stepping through that, nothing's going to change because we haven't changed our bounds yet. But now we're going to make our pretty much our first iteration guess. So calculate our first XR. And that's by using the equation we used in the last video, which is the x lower plus the x upper divided by 2. So we get our first XR to equal 7.5. That's good. That's following what we already did by hand. And now what we could do is calculate our function for fxr. So if you remember in our last video, we did use the function of xr to check where the roots are if they're in the between the upper and lower. So now what we need to use is an if statement to check where the root is. So that means what this here is saying is if the function of the lower bound times the function of our guess is less than 0, then our x upper is going to change to xr. And the x lower will stay the same. I could have written that, but write in xl equals xl. It's just staying the same. You don't have to write it. And then we have else if. So this is like basically the opposite. If the function of the x lower times the function of our xr is greater than 0, that means that there's no sign change. That means it doesn't lie in between xl and xr. Then our xl is going to equal xr. So then it's going to basically be looking at xr between our x upper from before. And then we have our last else, which is important to put just in case maybe somehow you actually guess the root, is x root. So if it doesn't, if none of these happens, that means that it's equal to 0. So the f of xl times, the function of xl times the function of xr is equal to 0. That's going to mean that the function of xr is going to probably be, is equal to 0. So if the function of xr is equal to 0, that means we found the root. So we're done. We did it. Then it's just going to give us our x root equals xr. And that will show up in the workspace here. And then we'll end that. So that's going to end our if statement. And this if I is greater than 1. So this is actually incorrect because I didn't calculate the absolute error the way though you can do it with the bisection method. I actually, in this code, I calculated the absolute error using I think this is used for a lot of other methods. I'm not sure exactly which ones, but this is like a common way. So absolute error is basically taking the error from your last one. So I calculated the absolute error to be the absolute value of xr minus xr old over xr times 100. So that's going to give it a percent. So this isn't totally correct. Just disregard this. We're going for our root, our guess. So this does work, but it won't work for the first iteration. And that will end that if statement. So after the first loop, it gives us our absolute error. And it's going to, at the end of it, it just says xr old is equal to xr. So that's going to make this xr old equal to the last xr. Because if you think about it, xr changes in this section here. So xr old will be from the last one because it's not before this. So order does matter a lot when you're coding in Matlab. Just something to point out. And then we get to the end, and that's it. That's pretty much it for the for loop. So we'll step through this the first time. So we get xr is equal to 7.5. The if statement got triggered because this was true right here. So x upper became xr, as you see here in the workspace. And that was our first iteration. So I'm just going to run the whole code. So after, we got to quit that out. So after 8 iterations, we get our xr, our final xr value to be 6.3867. And I remember the x root, which was given in the problem, was like 6.4. So this is pretty close. It's not too bad. And that's about it for this video. I just wanted to show you guys how to do bisection method in Matlab. If you guys have any problems or any questions that you would like me to solve, just leave them in the comments, and that's all. Thanks, guys.